Kia ora and welcome to Forest Call, Forestry telling its story. All of our land-based industries these days are looking at nitrogen possibly leaching through their production soils. Plants need nitrogen to grow, but if there's a surplus, the waterways may suffer. Scientists are trialling fertilisers for trees at more than 40 sites throughout New Zealand. They expect to see a 20% increase in tree productivity with these what they call accelerator trials. For forestry, the pumice country of New Zealand's largest plantation estate, Mycorrhizal, is an ideal place to test. The trees here could do with fertiliser, and the soil is porous. Amanda's using a simple device called a lysimeter, in what she calls a clip-on trial for nitrogen movement. The lysimeter collects nitrogen percolating through the soil with an isotope fingerprint to find out just how much the nitrogen percolates and where. And it's all measured down a rather deep hole. So this is pretty pumicey soil here, Amanda. If you're going to get nitrogen travelling in the soil, it would be through this sort of thing.
Yeah, absolutely. The really coarse material like that is incredibly vulnerable to leaching. And unfortunately, this site, because it's low in nitrogen, is a site where we would want to possibly add mineral fertilizer to help with productivity. So the question that we're asking in this clip-on trial is, okay, if we add nitrogen fertilizer, is it going to leach? How quickly will it leach? At what rate does it start to leach? And those are some of the questions that we can answer using this setup.
Okay, let's have a look.
All right. Okay, don't step on the pink squares. So each of these 3 squares is where I've added 15N, so stable nitrogen isotope. And if you track any of the 15N outside of these pink squares, I'm going to find it in areas where I shouldn't find it.
Okay. What's the difference? 1, 2, 3 different locations here.
So this is what we're looking at here are different surface forms. So if you look around you, the way that they have prepared the site before planting is they've done this mounding, which is quite typical. And what we're wondering is whether or not you're going to see different amounts of leaching directly under the mound where the tree is planted, in the interrow where you have far less vegetation, also less organic matter, and then in the slash pile over there where you clearly have a lot of organic matter. Organic matter can very often bind nitrogen, so it's quite likely we'll see less nitrogen leaching over there than we will over here. The other thing that we're using 15N for is looking at what's going on in the top meter of soil. So how nitrogen is partitioning over time, whether it stays in the ammonium pool, is bound up by the organic pool, is changed into nitrate. Nitrate, of course, being the most vulnerable form to leaching.
Okay, why do you go down that further metre? Why can't you generalise on what studies have done in the past of just 1 metre's worth from the surface?
We're doing 1 metre because we can then compare to other studies, which is of course really important. But the thing with trees is that even at this age, their roots are definitely below 1 metre. So if we only look at 1 metre and then we say everything after 1 metre is leached, that's absolutely incorrect, because you know that there are roots taking up water below 1 metre of depth. The idea here is we were hoping 2 meters would actually be below the rooting depth of these trees. As you can see, these pits are quite deep because we've dug down to 2.5 meters. So we can put lysimeters in at 1 and 2 meters and get a much better idea of what's going on below the rooting zone.
And you're looking for what with these lysimeters?
So we're looking for nitrates and ammonium, so mineral nitrogen that's come through the soil as a result of the fertilizer that we've added. Okay, this is one of our lysimeter holes. So what we've done here is we've dug horizontally into the soil and installed 2 types of lysimeters. We've got leachate collectors, which is what's attached to these hoses here. All the leachate gets collected in these containers. And then we have resin lysimeters, which look like this. So these are installed in there. As the water percolates through the soil, it percolates through our lysimeter. The resin in the middle of the lysimeter captures all of the mineral nitrogen, and we can come back 6 months later, 1 month later, measure how much nitrogen is in that resin, and that tells us how much has come through the soil in that period of time.
Our planted forest industry, challenging to be our second primary export earner. Wood's environmentally good in plant and product for building and landscapes. We're great in technology and science, selecting stronger, straighter trees, safer ways to harvest them, cleaner and earthquake-resistant ways to build. Forests, regionally vital for economic development, creating all sorts of jobs. A prime future investment for our nation. Love our forests. The science work is not just measuring soil nutrient movement and where they go in the soil and what they do in the trees. There's another fascinating relationship that's between the trees and the soil mycorrhiza. It's a beneficial fungus long known to assist trees to grow better. But the suspicion was that too much fertiliser and fungicide applied to nursery seedlings was too much of a good thing. It was harming the mycorrhiza, perhaps for years. Simeon is here inspecting a trial of trees he started off 10 years ago to see if by cutting back on the nitrogen and fungicides in the nursery, then the mycorrhiza would thrive more, and so too, therefore, would the trees.
These fungi are really important to the performance of radiata pine. They help them get nutrients, they help them get water, so they're really important to their early establishment and their survival. So working in a nursery, we basically increased or decreased levels of fertiliser and fungicide addition by 25% in all possible combinations. And leaving the nursery gate, we got some really interesting results showing that the seedlings that had reduced fungicide exposure had much better mycorrhiza on them. Not all mycorrhiza are created equal. Some species were clearly doing more for the seedlings than others. So that was all well and good, but we really wanted to see, well, what actually happens when you plant them out in the forest? How significant is the response of the ectomycorrhizal communities to reductions in fungicide and reductions in fertiliser? So in 2010 we planted these seedlings out, and then we've been monitoring them pretty much ever since, and we've got some pretty nice results which basically show the seedlings that were exposed to less fungicide in the nursery have a higher survival rate, and they've also been growing faster as well. So here we are now, a number of years later, in the basal area of the seedlings that had less fungicide way back, 8 years ago, back in the nursery. It's 8% bigger now.
Fertiliser type is another variable, not just time and volume. Some slow-release formulas are working very well at low rates.
Some of the products we've been looking at, they seem to be quite specific in their benefits towards conifers. So we're just exploring the limits of where we can use them and how we can most effectively use them. But so far, from all the perspectives we've been looking at, from economic and environmental, even from a human health perspective in terms of reducing the need to handle chemicals, it keeps coming up a winner.
To put the initial trials to a more thorough test, Science planted out 46 small-scale tests throughout New Zealand to see if slightly different treatments produced the same nursery legacy result in different environments.
There's a standard treatment, and then there's 3 other treatments as well, which all produced better quality seedlings than the standard, but they took different pathways to get there. So basically we've got 3 recipes that we're trying here to see which one of those recipes makes the trees best adapted to that site. We're confident that all of those recipes are going to be better than the standard conventional way of raising the seedlings, but we're trying to find what's actually the best for this particular site, and indeed another 45 sites that we've got in this trial series. The whole idea being it opens the door to raising seedlings specifically to match your particular type of forest. For example, we seem to have a recipe that seems to be doing particularly well for repopulating skid sites, which are really hard to re-establish trees on. One of our recipes seems to give the trees an advantage in that scenario. What we've found in the past for some species, not Pinus radiata, that the right mycorrhiza weren't there. Over the time in New Zealand, we've had a lot of problems establishing Douglas fir in some places, simply because there just weren't the right mycorrhiza for it. With Pinus radiata, we don't seem to have ever had that problem, but we still definitely have a case where some mycorrhiza are better than others. And one of the things that we're finding out about the differences between the genotypes of Pinus radiata, some genotypes are really good at recruiting those beneficial mycorrhiza than others, basically. It's one of the things that gives them their competitive advantage. So we're doing some really nice work in that area, which shows that that whole microbial dimension to forest management is really quite powerful, but it is also something that we can manage in an effective and sustainable way as well.
By doing what?
Basically selecting a genotype for a site that is going to work with the mycorrhiza in that environment. That's the sort of level of precision that we're approaching, and our studies have shown that it is actually happening, so we may as well try and use it as a management tool.
At Patrick Murray's nursery here at Woodville, there's plenty of mycorrhiza among the pine seedling roots. Proof of the reduction of fertiliser and fungicide applications is in the soil pudding.
So what we're looking at here on the Pinus radiata seedlings is mycorrhiza, and the mycelium is the white that you're seeing. You're also seeing a lot of root clusters on the lateral roots in here, What that does is massively increase the root surface. Another feature you're seeing here is the lateral root initiation. So the initiation of lateral roots is very high and very close to the root collar, which is high in the soil level. So what we're looking at here is mycelium at ground level, and this is a particular feature of that reduced fungicide and fertiliser applications. So where we've eliminated fungicide completely, it's a very safe zone. So the mycorrhizal activity is occurring at ground level, and then as we pull the trees out, you can see it in the root formation and all the way through the soil. So that it's a very high level of mycorrhizal activity, and you can see the benefit in the trees and their robustness and their health. Also, what we have here is one of the fruiting bodies from the mycorrhizae, and this is what's releasing all the spores. So this is the tuber that you're seeing, and that decays and releases millions of mycorrhizal spores. So the more chemicals you put on, the lower you will see that activity developing. And so if you think about the seedling and the root length, it's about having that volume of root clusters and mycorrhizal activity over the entire taproot length.
Patrick Murray set out on a 5-year course of gradually reducing both fertiliser and fungicides.
At the end of that 5 years, we were able to completely eliminate fungicides in the nursery for 2 years. We produced 8 million seedlings without the use of fungicides, and we also worked on reducing our fertiliser inputs as well.
Does the dice always roll well?
It doesn't always roll well. Last year was probably the worst, so we had 2 really wet summers. We expected spore counts to be up, and we had to intervene last year to manage a bit of terminal croc. And so we're pretty confident with another good season. We're back to fungicide free and significantly reduced fertiliser applications. So we're down to 40% of our original fertiliser applications. That equates to 240 kgs of nitrogen net over 6 million trees, so it's quite insignificant. We hope to be able to get to micro-dosing liquid fertiliser only, primarily nitrogen, and that would be an ultimate goal. And fungicides only on a responsive regime rather than a preventative one. That would be a great outcome in terms of sustainability and in terms of the crop health.
So we have opportunities to really go in and affect seedling quality as opposed to waiting for natural regeneration as occurs in a lot of other forest environments. And again, when these international collaborators have visited us, they've looked at what we're able to do with our mycorrhiza, and again, taking it to an applied level is just not something they have the facility or the capacity to do yet. So we really are at the sort of the head of the game when it comes to this space. So there are opportunities to make quite an impact, not just within New Zealand, but to lead the way for forestry globally.
The debilitating red needle cast. This fungus is rapidly becoming the emerging disease of pine plantation forests throughout New Zealand, including here in eastern Wairau.
Well, when I applied for the job at MCH, they offered me the opportunity to go to this course to get all my start-off tickets, and I just couldn't pass up the opportunity. They gave us all our entry tickets into the forestry, all our basic operation ones, and then they also gave us all the basic instructions on operating a grapple digger and everything we need to know to get started in operating diggers. It was a brilliant course, it was really good. It wasn't very academic, it was a very good balance of practical work and also theory work as well.
I'd spent some time with Richard Stringfellow, who obviously is tied up with Toi, my in Rotorua there, and I really like the principles of what they're doing there. You know, we really need to get behind and get people in the industry. You know, industry as such has got a bit of a bad rap at the moment, and there's not a lot of good things coming out about forestry. So we thought, bugger it, we'll get them behind Toyomoi and give it a shot.
Came back down, I had all the tickets I need to get into the bush, and I started straight in. I've done a bit of time in the bell, and I've also got my quality control experience, doing size checks, checking knot specs, lengths, all the basic specifications for the log grades we have. I've done some digger work, shuffling and making piles for the hauler and Waratah. So I've done a bit of time in the Waratah as well. During smokers I've been cutting trees up and doing what I can. I've also moved the towel hole for the hauler. That was one of the first jobs I'd done when I got back, actually, was in the towel hold.
The days of training a guy up to do manual tree filling, manual breaking out and manual line shifts, they are a skill that we still need to have, but you know, we need to look at the topography we're harvesting and the machinery and technology that we've got available, and a lot of that is around machines. So Toyomoi offered the 3-month simulator style training with also covering off all the basic general entry into forestry, which I thought was a really, really good touch.
I think there's definitely growth in the industry. You're always going to need wood. You can't replace it in a lot of industries these days. So I think it's going to be one of those industries that's never going to die.
You know, I honestly think Toyomoi is a great facility. I think everyone should get behind it, to be honest, and support it. The actual facility they've got in Rotorua is second to none to anywhere else in the country. You know, and I must admit it concerns me that it's probably not used to its full potential. And I think everyone should. Any contractor should look at it and go, shit, we need to get behind this place and give it its full support for what Richard and the team do there.
Obviously you've got to start from the bottom, work your way up, and I do see myself eventually moving up. Maybe eventually in a few years' time into a more senior role, and then maybe one day possibly own my own crew.
When some pest or disease gets into our forests, we try to get rid of it, but some pests and diseases are horses for which it is pointless to try to bolt the stable door. But all is not lost. It's time to work on controls. In this case, it's the emerging disease of the pine forest industry, now found throughout most of New Zealand, red needle cast.
This is the first sighting of it in this area. It was the first time this year. And funny enough, I was in the prior to a track last year, so it sort of spread east. It has an effect where it will slow down the tree growth this year, sort of by about 40%, and hopefully next year it won't be here, so the tree will carry on growing. It'll take a few years for the tree to recover, and then it'll be away again.
As long as it doesn't come back?
As long as it doesn't come back, yeah. Hopefully it won't.
Red needle cast has been around for about 10 years in New Zealand, causing problems, and it wasn't known anywhere before that. And it was first found on the east coast of the North Island, and work on the pathogen that causes it, which is a species of Phytophthora, which is a fungal-like microorganism, indicates that it comes from the northwest of the US, which is the only other place where it's been found. In bad years, like last year and this year, in certain areas it can cause an almost complete defoliation of the tree over winter. The trees do recover over summer, but that loss of green photosynthetic tissue at the start of the growth season can cause significant growth losses up to about 40%, we think.
Why can't we use the same spray program we use for Dophostroma to knock out red needle cast as well?
Copper is showing promise in controlling red needle cast as well as Dophostroma, but both pathogens, both diseases like wet conditions, but red needle cast expresses over the winter, whereas Dophostroma expresses over the summer. So at the moment for Dophostroma, they do a spray in kind of November time and February time, and we think a kind of later spray, February onwards, would probably be better for RNC as it expresses over winter, but we are doing work in this area.
So in effect, you're doubling the spray program to also hit red needle cast because of the opposite season?
Potentially. The other issue is Dophostroma only affects plants up to about 15 years of age, and rotation lengths of about 30 years and red needle cast affects plants after this 15 years, so you would potentially have to extend your spraying program as well.
So in effect you're talking about quadrupling the application of copper sprays to control both diseases?
Potentially, yes. This disease kind of booms and busts. So last year it was widespread throughout the North Island and north of the South Island. And we put in lots of trials. And then this year nothing happens. And this seems to be a running theme. It kind of peaks every second or third year.
The technology of remote sensing UAVs, aircraft with cameras or satellites is ideal for forest management. A quick scan from above is worth months of wandering around underneath, no matter how many tape measures and clipboards you have. The data can be used to look for outbreaks of pests and diseases, or work out when it's best to harvest. But there's another use, to spot the super trees among the ordinary ones.
For quite a few years now, UAV manufacturers have been turning up at Forest Tech, and it's been cropping up a lot in international forestry about how UAVs could be useful in forestry. So about 4 years ago, as part of the GSIF project, Scion decided to purchase a UAV and this laser scanner as well. The sensor itself sits here. We've got the actual lasers sitting here, and this spins round at a rate of knots. Which then sends out a span of lasers to scan what's passing underneath it. You can get models these days which have an internal IMU. This one relies on the data coming from these two GPS antennae to tell the unit where it is so that it can work out what it's scanning in relation to where it is. But not the sort of thing you can fly off the smaller crafts, obviously, but yeah, with the sort of crafts like this becoming more affordable and sensors like this scanner becoming cheaper, it's the sort of thing that we'll probably see in forestry a lot more commonly in the future. And it was really just to sort of see, is it a tool or a toy? And I think the fact that we're still here after 4 years is probably good for us to see that it's become quite an operational tool.
So we take the point clouds that are generated from that LiDAR, detect and delineate individual trees in the point cloud, and then characterise those individual tree crowns, generating metrics. So here we have a map that indicates trees of superior or inferior height growth due to their genetics, with the environmental effects minimised. The idea would be to collect DNA on those trees and take that into the breeding program to produce superior trees in the future. Once we've analysed each individual tree crown and extracted information about it, we can take some of those key metrics and represent them in a sort of a digital version of the stand of trees. So in this case, we place an icon at each tree location, and that icon represents tree height, crown width, and crown depth. So we have this little umbrella model for each tree where we can control those dimensions of the model, and then we can create a map showing our area of interest with those virtual trees. We're very fortunate here to have coverage of the entire Kaingaroa estate, so it's been kindly provided by Timberlands, and that gives us a huge resource to work with. And so I'm able to analyse that and screen stands across the entire forest, and by taking account of the variations in environment and different seed lots that have been established across that forest, we can home in on stands of interest and then go further down and right down to trees of interest within those stands. So the concept here is treating this huge forest as an experiment, and by combining this remotely sensed data with the very detailed records that the forest managers have collected and made available, it means we can start to really explore these questions about the drivers of growth. So we've characterised all the trees in this area using LiDAR, and we've used a crown metric called crown volume. So that's a measure of crown size, and we've found that that correlates very well with DBH, or diameter at breast height. So this is a basic measure of tree size. We've also found that crown metric correlates very well with total stem volume. We've identified this tree as performing better than its neighbours. So in the analysis, we've taken account of local microsite effects, and so we've been able to quantify patches within the stand that are growing better or poorer due to environmental effects, and we're able to take that into account and then extract the residual, which is the genetic component of the growth. And so what we're doing is targeting trees that have superior genetic performance.
I think we'll take a walk in here and look for these 2 red trees, which Dave's identified as potentially being large trees for the area, and we'll walk onto them with the traditional Garmin, and when we get there we can confirm the location.
We're looking for initially CT038.
CT38?
Yep.
Okay, so first tree of interest is 32 metres away down there.
Okay.
10 metres.
10 metres-ish from here. Okay, yep, I think we might be walking past this big one. I can see that here.
So we're here.
This is the tree of interest right here.
Even though this is a tree that has met Dave's criteria, it's got a big crown, it's a reasonable volume for where it is. From a breeding perspective, the visual check on the ground, it's not straight enough. So we're going to move on and look for another tree.
We're looking for CT38 initially, but I can see on the map it's quite a small crown. I'm not convinced that that will be a good candidate actually. It was probably rated highly on the computer because it has several large trees surrounding it. So its performance is relatively good rather than it being a big tree. It's probably a medium-sized tree but performing well given the level of competition it's experiencing. But there's also another tree nearby which was of interest. That's CB21. We might look for that. The computer provides us a method to very quickly screen. You know, in this stand I believe there were of the order of 10,000 trees. So we don't need to visit every tree. We can have sifted through and come up with, in this case, a set of 100 candidate trees that we would come and visit and verify their suitability.
In this part of the forest, trees are generally bigger in the northern facing slopes. So if we found a really good tree on a southern aspect and it was in a competitive situation, we would know that was a pretty special tree, because not only is it environmentally disadvantaged, but it's had to beat its neighbours as well. The southerly aspect, the blue is a shorter tree height. Mm-hmm. So all this north stuff, much easier to find big trees, but big trees down in here are probably more interesting.
Pattern of crowns is easier to interpret in the younger stands actually, because partly here it's to do with tree lean and so on. The tops of the trees, which is what this image is portraying, are a very long way above us, and quite a lot can go on between the top of the tree and where we are down on the ground.
All right, 20 metres to go. So we've arrived at this tree here. It's a big tree, it's a straight tree. For where it is, it's probably been advantaged a little bit. It's on a north face, so nice environment. A few of its neighbours are missing, so it's had a bit more space to grow in. We'll put this into the next stage. So the next stage is mark it up, get increment core to work out the density of it. We'll bring an acoustic tool to get an estimate of the stiffness at breast height. And then lastly, because this stand, we know the genetic origins of it, because it's seed orchard based, we will take a bark window out and take a sample of cambium back to the lab. And the girls in the lab should be able to, with DNA fingerprinting, tell us who mum and dad are for this tree. And that's one of the overall sampling things. We need to make sure we're not sampling in the same families all the time. So that will be one of the final hurdles. It's big, straight. If wood properties are acceptable, we just need to monitor the genetic diversity of trees that we select using this process.
And all of the projects we've seen Cyan working on in this episode of Forest Call receive funding from the Forest Growers Levy. The Forest Owners Association and MPI have just finished these 28 forest practice guides. They give forest companies, especially the smaller ones without an in-house resource, and local government, the best practice formulas to help their way through the National Environmental Standard for Plantation Forestry, which came into force in May. Go onto the FOA website and look for Forest Practice Guides. That's the end of this episode of Forest Call. and the end of the series. It's gone so very fast. We've had our downfalls and filmed from way up in the air. We've poked the borax at plastic, but it's plastic.
It's plastic.
We were a huge industry when the series began, and now, in just the space of a few past weeks, real signs that forestry is to become our main export industry inside 30 years. Wood to build with, and now wood for carbon sequestration to fight climate change.
Because climate change is the challenge that defines my generation.
A reminder now that there is a vote on the Forest Growers Levy early in the new year. We have a website up on it. You can go on there to find out about the round of industry meetings around the country to talk about the levy. Levy vote is a crucial decision, a few important points to bear in mind. In the context of funding the industry good work for what is now a $6 billion export industry, plus domestic, a few cents a tonne levy is modest indeed. It's also highly leveraged. Other funds, especially government grants, become available when an industry is prepared to put its hand into its own pocket. But also, forestry is the industry with the most guaranteed growth curve of all the primary sector. It needs to keep up in so many ways with the huge expectations and challenges. Thanks now especially to three people who are vital in making Forest Core, and me, work. Donna McKenna Studios, Guy Pottinger from Dive Productions in Wellington, Andy Jack from Face TV here in Auckland, three cameramen, Ron Michael in Rotorua, Dave Perry in Christchurch and Bjorn Arman in Gisborne. Thanks as well to Dermot and all of the foresters and forest companies who gave so generously of their time, locations and the vehicles to get there. Likewise, the people at Scion. It's indeed been a privilege. I hope you and other industry colleagues feel that we've managed to tell your story as well. I trust all of you watching from outside the industry have picked up something of the forest story from Forest Core. Thanks also to Forest Furniture up on the North Shore. You can have your magnificent Cody table back again, but be quick about it. So much we have yet to tell. I'd have loved to take you to the Timber Museum at Bataradu. We could have done a whole episode on methyl bromide, the fumigant for most of our export logs, but for which the clock is ticking. A whole series on farm forestry, how farmers can get the most out of planting trees. Biofuels is another one we didn't get a chance to touch on. We didn't do willows and poplars for erosion control either, so maybe another time. But to finish this time, a farewell summary by one of our industry leaders. Ka kite.
The future is fantastic. This is the best of times. Today, next year and for the coming decades, we see great opportunity. Big marketplaces. New Zealand's a fantastic place to grow resource, and it's something that we should be doing and doing lots of. To double the estate, fabulous idea. We're all for it.
1.7 million hectares of our planted forests. Trees locking up millions of tonnes of climate change surplus carbon from the atmosphere, then storing it in our buildings. Standing forests binding the landscape, cleaning waterways and absorbing floodwaters. A sheltering habitat for our endangered birds. Forests as places to ride your bike, go for a run. Treescapes for a fun time, sweat or relaxation among the trees. Love our forests.